So here we shall explain some practical problems on the union and the intersection of sets. So we know that if we have this is suppose the universal set which is represented by a rectangle, and we have two sets A and B which are represented by two circles. So now so here suppose here A and B are finite sets. So if A and B are finite sets, it means that the number of elements is not infinite. It is a finite real number. So then if A intersection B that is equal to phi, it means that if they are disjoint sets, it means that a set A and set B are like this. There is no common intersection region of these two sets. Then we can say that the number of elements in the set A in union B, it will be equal to the number of elements in A plus the number of elements in B. And then the number of elements in the set A union B, that can be written as and if, okay, and if A intersection B is not phi, if A intersection B is not equal to phi, it means that there is some common intersection region. Then the number of elements in the set A union B, that will be equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. And then the number of elements in the set A minus B. A minus B, it means this region. A minus B, it means this region. A, which is in A but not in B. It means I can say it is the number of elements in A intersection B complement. You can say that is number of elements in A minus the number of elements in A intersection B. And then the number of elements in the set B minus A, that can be written as number of elements in A complement intersection B. B intersection A complement. So it means this region, this is set B, this is set A. So we have to find the number of elements in this region, which is in B but not in A. So that will be number of elements in B minus the number of elements in A intersection B. And then suppose we have got three sets A, B, and C. A, B, and C if we have, then the number of elements in the set A union B union C, so that will be equal to number of elements in A plus number of elements in B plus the number of elements in C minus the number of elements in A intersection B minus the number of elements in B intersection C minus the number of elements in C intersection A plus the number of elements in A intersection B intersection C. So A intersection B intersection C is this region. This region is the A intersection B intersection C. So these are some of the formulas which we can apply to solve the following examples. So for example, if it is told that if X and Y are two finite sets, if X and Y are two finite sets such that X union Y has 50 elements, X union Y has 50 elements, and X has 20 elements, X has 28 elements, and Y has 32 elements. Y has 32 elements. Then how many elements does X intersection Y have? And how many elements does X intersection Y have? Now, therefore, the number of elements in X union Y, that will be equal to 50. The number of elements in X, that is equal to 28. Number of elements in Y, that is equal to 32. And then we have to find number of elements in X intersection Y, that we have to find. So now, therefore, we know that the number of elements in X union Y, that is equal to number of elements in X plus number of elements in Y. So these are given and we have to find this. So number of elements in X union Y, that is equal to number of elements in the set X plus number of elements in Y minus number of elements in X intersection Y. So therefore I can write 50 equal to 28 plus 32 minus the number of elements in X intersection Y. So it means the number of elements in X intersection Y, that will be equal to, this is 30 plus 30, that is 60. 60 minus 50, that is equal to 10. So this is equal to 10. And then we can, so 10 is the answer. Okay. Then we can give one more example. Suppose here it is told that there are 200 individuals. There are 200 individuals with a skin disorder. 200 individuals with a skin disorder. 120 had been exposed to the chemical C1. 120 had been exposed to the chemical C1. 50 had been exposed to the chemical C2, and 30 has been exposed to both the chemicals C1 and C2. 30 to both the chemicals C1 and C2. Then find the number of individuals exposed to chemical C1 but not to chemical C2. Then find the number of individuals exposed to the chemical C2 but not to chemical C1. And third question is, find the number of individuals who are exposed to the chemical C1 or chemical C2. Exposed to chemical C1 or chemical C2. Okay, so then we have to solve it. The solution is so 200 individuals with a skin disorder, 120 has been exposed to the chemical. Okay. So let's say this set, the set A. This is the set B. And this is the universal set, set U. So N of U, that is equal to 200. It means the number of individuals with a skin disorder. So now let the set A represent. So U is the universal set which represents all the individuals all the individuals with skin disorder. A, the set U, the universal set consists of all the individuals having a skin disorder. Now, the set A is the set which contains all the individuals um, who are exposed to the chemical C1, exposed to chemical C1. And let's say the set B, it consists of all the individuals who are exposed to the chemical C2. It it consists of all the individuals who are exposed to the chemical C2. Then so A intersection B, so I can say that A intersection B is the set of all the individuals who are exposed to both chemicals C1 and C2, to both chemicals C1 and C2. So then we have to find the number of individuals exposed to chemical C1 but not in C2. So it means here we have to find exposed to C1 but not in C2. So it means A minus B that we have to find. N of A minus B that we have to find here. And here we have to find the number of individuals who are exposed to chemical C2 but not to chemical C1. It means we have to find N of B minus A. And here we have to find the number of individuals exposed to chemical C1 or chemical C2. So that will be so it will be A, N of A union B. So now we have to find N of A minus B. So that will be equal to that will be equal to N of A minus N of A intersection B. So that will be equal to so here so so now therefore here we can see that the number of elements in the set A, it means all the elements all the individuals who are exposed to the chemical C1, that is given as 120. So this N of A is 120, and N of B, that is the number of elements in the set B, that is the number of individuals who are exposed to chemical C2, that is 50. So N of B is 50, and N of A intersection B, it means the number of individuals who are exposed to both the chemical C1 and C2, that is 30. Is 30. So now N of A minus B, that is 120 minus 30, so this is 90. And N of B minus A, so that will be N of B minus N of A intersection B. So that will be equal to the number of individuals who are exposed to the chemical C2 but not to the chemical C1. So that is 50 minus 30. 50 minus 30. C1 and C2. Okay, so 50 minus 30, so that will be equal to 20. And then we have to find N of A union B. So that is the number of elements which are in either A or B. It means the number of individuals who are exposed to either C1 or C2. So that will be N of A plus N of B minus N of A intersection B. So that will be equal to is 120 plus 50 minus 30. So that is 120 plus 20, that is 140. So these are the answers. So hope you have understood the concept of the sum. So how to solve some practical problems on the union and intersection of sets. So thank you.